A1x having a positive slope A2 by A1 and passing through the origin. Now our aim is to find the direction of a motion. This is the straight line. So resultant motion is rectilinear and takes place along a diagonal of the. Okay, now we will find the direction of the motion. In which direction or how the particle will propagate due to the simultaneous application of two perpendicular harmonic oscillations having same frequencies and phase difference 0. That is delta 0. So when delta equal to 0, we can write x equal to a1 cos omega t and y equal to a2 sin omega t, cos omega t. Now how you will find the direction? In order to find the direction, first point out some points. Suppose when omega t equal to 0, what will the value of x and y? Make a table like this. When omega t equal to 0, or we can say t equal to 0, in that case, this will be a1, a2. Now when omega t equal to pi by 2, 0, 0. When omega t equal to pi, what will the value? Minus a1, minus a2. Everybody clear? So now we have to plot. In order to show this one, now we find out the point. Suppose this is 0, this is x-axis, and this is y-axis. We have to find, suppose a1 minus a1, a2. These are the amplitudes of SHM1 and 2 respectively. So A1, A2, this point, then 0, 0, then this point. So all of you mark out. First, we have obtained this point, suppose P, then 0 or O, P, O, then suppose P prime in this direction. So direction of motion, very important. Without this direction of motion, half of the marks will be deducted. So direction will be from P to O, then O to P prime. Again, if you take, this is pi by 2, pi, then 3 pi by 2, again you will get 0, 0, and 2 pi, you will obtain this one. So direction will be like this. Everybody clear? If any doubt, you can ask. How you will obtain the direction? This detailed explanation is given in that book. Already I have said that reference books you can follow. Sorry, test book that which are given in your syllabus. And some study material also I will upload after not today, if possible. I will say when I will upload. If I will complete it today, then I will upload. Otherwise, tomorrow I will take your class at 9 o'clock. After that, I will upload the study material of superficial. So this is the case when delta equal to 0. Everybody clear? What is the their resultant motion, and this is very important, is the direction of motion. First you have derived the general equation of motion, then substitute delta equal to 0. For that case you have obtained. Now consider case 2 when delta equal to pi by 2. So this is known as, so when delta equal to 0, this type of motion is in optics. It is known as linearly polarized vibration. This is known as linearly polarized vibration. In optics, I think you will read what is polarization, etc. After that, you will be clear. You will be clear what is this. So this type of vibration is known as linearly polarized vibration. Now we will discuss about case 2 when delta equal to pi by 2. When delta equal to pi by 2, in that case You see the general equation of motion was your equation number 5. You substitute delta equal to pi by 2. Then you will obtain cos delta 0 and sin delta 1. So in that case, you will get x square by a1 square plus y square by a2 square, that is equal to 1. What is this? This is an equation of, anybody? This is an equation of
Ellipse.
Not ellipse.
Ellipse.
In a particular case, when a1 equal to a2, that case equal to circle. Okay. So this is the equation of an ellipse, whose principal axis lie along the x and y axis. This is an equation of an ellipse whose principal axis lie along the x and y axis. Now our aim again to find the direction, in which direction the particular element. If it is acted by two SHMs which are perpendicular and having same frequency and phase difference delta equal to pi by 2. So in that case also, if you will substitute delta equal to pi by 2, you will obtain a1 cos omega t, and this will be y equal to a2 sin omega t plus pi by 2. Okay, that will be minus a2, this is cos sin omega t. Okay, now like previous, you make omega t equal to 0, the value of x and y. Similarly, when t equal to 0, omega t equal to 0, then omega t equal to pi by 2, then pi, then 3 pi by 2, then 2 pi. At least these 5 points you can take, then you connect those points, then you will get the direction of motion. In this case, if you take the points, you will get the motion like this. And the direction like this. So this is known as, in optics, this is known as right-handed elliptically polarized vibration. Right-handed elliptically polarized vibration. This type of motion is known as right-handed elliptically polarized vibration. Now, if you will consider another case, already one of your friends said circle. When we will consider a1 equal to a2 equal to a, then in that case, the equation of motion will be x square plus y square equal to a square. So what is this? This is the equation of a circle. So we can give the conclusion like that. Due to the again you will listen what we have taken, superposition of two perpendicular harmonic oscillations having same frequencies, phase difference pi by 2. Phase difference pi by 2. And another extra point we have taken, the amplitudes are same. Then we will get the circular motion. Everybody clear? So we can write like this. Two harmonic oscillations or two perpendicular harmonic oscillations having equal amplitudes and equal frequencies. Having equal amplitudes and equal frequencies, but with phases differing by pi by 2 are equivalent to a uniform circular motion. The radius of the circle being equal to the amplitude of the oscillation. The radius of the circle is equal to the amplitude of either oscillation. We have taken A1 equal to A2, sorry, A1 equal to A2 equal to A. Hence we can say that amplitude of each oscillation, each SHM is A. A1 equal to A and A2 is also A. Conversely also we can say,
Sir, how we can say the major axis of ellipse will be x-axis?
You can. How?
We don't know the amplitude. How we can say the major axis of a ellipse will be x-axis?
You may take a y-axis. What will be the problem? The direction will be same. And you are getting the points. You are getting the points accordingly. If it is, suppose you are saying ellipse means what is this? If this is ellipse, I can write this is also ellipse. Is it not? If it is your A1 is greater than A2, then it will be like this. Otherwise, it will be like this.
So the direction defines the right-handed elliptically.
Yes, you can take. You take the points here. First, in previous case, what we have taken, at when omega t equal to 0, you find the value of x and y. Put that point here. Suppose. Then another point you will get here when it is pi by 2, and when it is pi, you will obtain this one. So from this to this, you will obtain like this. You take the points and you plot by your own hands, then exactly it will be. Okay. If you are facing any problem, then also you can ask in the next class. There is no problem. You take these at least 5 points that when 0, pi by 2, pi, 3 pi by 2, 2 pi, and only join those points, then you will obtain. Since already the equation said it is elliptical, then you will join like this. You find out the points. Your ellipse, you are saying that how your major axis will be like this. It may be like this. It depends upon the value of A1 and A2. That means the amplitudes of SHM1 and SHM2. Similarly, for other cases, that delta case 3, that delta equal to pi, case 4, and delta equal to pi, all of you will try. Details in the study material it is given. And for delta equal to 3 pi by 2, also you will see that in case of a delta equal to pi, you will obtain that the equation of motion will be like y equal to minus a2 by a1.
ऐसा बिल्कुल भी नहीं है और क्लास में आओ और क्लास में सारा कुछ याद करके समझ के सब जाना है घर पे सिर्फ रिवाइज करना इसकी गारंटी
When you substitute the value of delta equal to 3 pi by 2, first in the general equation of motion pi, find the equation of motion, procedure is the same. Then you will get the equation of motion. After that, you take delta equal to 3 pi by 2 in our original equation number 1 and 2. Then you locate some points, at least 5 points, what I said, that omega t equal to 0, pi by 2, pi, 3 pi by 2, and 2 pi. Then you will get the equation of motion. For these points, in that case, that was right-handed, it will be left-handed. Okay, so these points, all of you will try to do by yourself. Next approach.
So can't we take pi by 6?
Anyone, you can take any value. Then you have to find what is the value of a sine pi by 6. But for simple calculations, I have taken pi by 2 or pi by 3 pi by 2 like this. You can take any value. Omega t may be any value. Up to 2 pi you can take since we have taken any value. Then you have to calculate what will be the value of pi by 6, sine pi by 6, cos pi by 6. Then you have to find the equation of motion and fractional values of x and y. You have to plot the graph. Okay. In the book also it is shown when delta equal to 0, pi by 4, pi by 2, 3 pi by 4, pi, 5 pi by 4, 3 pi by 2, 7 pi by 4, and delta equal to 2 pi. There are 9 figures are given. All of you should try those things at least once in your home. This is analytical method. In graphical method, I said there are different. In graphical method, what you will do, I am saying the technique. You will draw two circles, circle 1 and another circle here 2. Such that they are ready as equal to the amplitudes of the SHMs. We have taken one is your x equal to A1 cos omega t. That is along x-axis. Another we have taken y equal to A2 cos omega t plus delta. So if you consider this is
नो 25,000।
अरे 50 है।
25 है।
500 कितना है?
50 को।
ये जो 550 है।
फिर से गिन देगा लोग।
Who are you? Hello.
ये एक्टिवेट करा दो।
ठीक है 50 ही है। मैं तो रुक जाओ, मैं एक तरीका से गिनूं, उससे इम्पैक्ट हो जाएगा दोस्तों। मैं आपको 10-10 देते जाऊंगा, आप चेक करना मैं 10 दिया हूँ कि नहीं, और फिर थोड़ा
100 है कि नहीं।
Okay, we listen. What we have done here, this is omega t. So x equal to, you see, if we are considering the first along x-axis, then we have to consider this is A1 is the radius of the circle. Now, at any point in the circle, suppose P, we have taken P2 into P1. So the projection of O1 P1 will be A1 N1, and we have considered this value as x. Then you see this is A1. So your cos omega t, that cos omega t, that will be x by A1. So x equal to A1 cos omega. So this circle represents the SHM1. Now, at any point, suppose it is at P1, so the O1, the projection of A1, O1 P1 is O1 N1. That will represent the motion of the particle at any instant of time. Similarly, here we have considered the angle is omega t plus delta, and O2 P2 at any point. At any instant of a time, the point is at P2. So the projection of this O2 P2, that is O2 N2, this is Y. So Y equal to A2 cos omega t. From this circle, we can find that Y equal to A2 cos omega t. Now, when the particle is subjected, suppose there is one particle, and if this SHM is acted upon the particle only, Then the projection of O1 P1, that is the motion of O1 N1 represents the motion of the particle. Similarly, if the particle is acted by only the SHM2, then the motion of O2N2 will represent the motion of the particle. Clear to this point? Now, when we are considering both the SHMs are acting upon a particle simultaneously, then if we draw their intersection, we have drawn the perpendiculars, their intersection P, and this is O. So this OP will represent the resultant motion due to the superposition of these two SHMs on the particle at any instant of a time. For example, if you consider a delta equal to 0, then how you will obtain the motion? For delta equal to 0, this is the general procedure. This method is known as double application of a rotating vector technique. Double application of a rotating vector technique. So the path followed by the point P as time passes gives the resultant motion. Double application of the rotating vector technique. Now let us consider case 1, that is delta equal to 0. If you consider delta equal to 0, then what will be the equation of motion? Your x equal to a1 cos omega t and y equal to a2 cos omega t. Now here delta is not required. Delta is 0. Now draw two circles, taking a1 and a2 as they are ready. Now you can divide each one into 8 parts. So you will see that delta equal to 0. So numbering will start from when omega t equal to 0. This reference parallel to x-axis, omega t equal to 0. Then 1, 2, 3, 4, 5, 6, 7, 8. I have number of this one. Now comes to second one. Your second one is parallel to or along y-axis. So the numbering will start from 0. Then 1, 2, 3, 4, 5, 6, 7, 8. Everybody clear about the numberings? After that, you draw perpendiculars from the same numbering. You will obtain here the point. This is 1. Join the same numbering points. 1, 1. This is 1 point. This is another point. 2, 2. This one and this one. Then this point. 3, 3. You will obtain. In this way, you will get the points. Now you have started from 0, 0. So direction will be like this. This is also another point. 4, 4. Again, it retraces its path. So you see what we have obtained in analytical method. Now we have also obtained in graphical method. Everybody clear? How we have obtained this direction of motion as well as the points to represent the resultant motion due to superposition of two perpendicular harmonic oscillations having same frequencies. Everybody clear? For other cases, all of you will try. For example, now you see it is divided into how many parts? 80 parts. If you take here delta equal to pi by 4, then what will happen? Your numbering will start, because here numbering will start from here. Instead of a 0, your 0 will start here. Second one. Why? Because each part, your delta by 4. This angle is delta by 4. So numbering will start from this place. Then you will add like this. Same numbering points you draw. Then you will obtain like this. The directions you will find. Everybody clear? how the numbering is given. In previous case, when delta equal to 0, we have started here. Now, since here delta equal to pi by 4, so here numbering will start from this place. This is the angle pi by 4. Then you will draw the perpendiculars and join the same numbering points, you will get the exact path followed by the particle due to application of this kind of forces. Okay. So this is the superposition of two perpendicular harmonic oscillations having same frequencies. Now we will discuss about the superposition of two perpendicular harmonic oscillations having different frequencies. Having different frequencies. The resultant path due to the superposition of all of you listen carefully. I will upload the study material. You go through the textbook already. I have said it is given in detail in the book. Study material, some skeleton will be given there. Then you will make your own note. Reading books and this study material for your examination point of view will make your own notes. So the resultant motion due to superposition of two perpendicular harmonic oscillations having different frequencies is known as Lissajous figures. Is known as Lissajous figure. Again, I am repeating. The resultant motion due to superposition of two perpendicular harmonic oscillations having different frequencies. Already we have discussed about same frequencies. In the same frequencies, we have got the expression in general elliptic. Then we have obtained different cases, delta equal to 0, delta equal to pi by 4, etc., etc. 3 pi by 2, pi, etc. Whatever. Now we will consider the superposition of two perpendicular harmonic oscillations having different frequencies. So the resultant motion due to superposition of two perpendicular harmonic oscillations having different frequencies gives Lissajous figure. So we can write a Lissajous figure is the resultant path traced out by a particle when it is simultaneously acted upon by two perpendicular SHMs. Two perpendicular SHMs having different frequency. Two perpendicular SHMs of different frequencies or having different frequencies. Everybody clear? Now we will discuss analytically. Analytically means we have to take the equation of motion, and in this case, when the frequencies are different, all of you listen very carefully, it is very difficult to get its resultant path. So we have, if you will consider any ratio, if you will consider a particular ratio, the frequencies in a particular ratio, for example 1:2 or 1:3 or 2:3, etc. If you will take the frequencies of a SHMs are in a particular ratio, then we will obtain the periodic motion. If you will take the frequencies haphazardly, then the resulting motion is not periodic, it does not repeat itself. In such case, the particle will describe an endless path. So it will be very difficult to represent. It is not impossible, but it is very difficult to present their resultant motion due to superposition of two perpendicular harmonic oscillations having different frequency. So in order to get a periodic motion, or for simplicity, we have taken the frequencies in the ratio 1:2. Everybody clear why we have taken the frequencies in a particular ratio in order to obtain the periodic motion? Or what will happen if we will not take in a particular ratio? The motion will not be periodic and it does not repeat itself. In such case, the particle will describe an endless curve. So it will be very difficult to trace the path of the particle. Now, consider the frequencies in a particular ratio 1:2. So we can write x equal to a1 cos omega t, and another one we can write a2 cos 2 omega t plus delta. Clear? Frequencies are 1:2 ratio. Phase difference is delta. So the result, the shape of the Lissajous figures can be obtained either by analytical or graphical method. First, we will try to obtain the resultant motion or Lissajous figure by analytical method. The procedure is the same. From this equation, you can find out the value of cos omega t. Where cos omega t equal to x by a1, hence sin omega t equal to square root of 1 minus x square by a1 square. I think everybody know this thing. Now, from equation number 2, we can write y by a2 equal to cos 2 omega t cos omega t minus sin 2 omega t. I think everybody knows this one. Cos A plus B using the formula cos A cos B minus sin A sin A. So we can write again cos 2 omega t. What is that formula? 2 cos square omega t minus 1 into cos delta. Then sin 2 omega t, 2 sin omega t to cos omega t and sin omega t. I think everybody knows before you are strong in mathematics before appearing in JEE main examination. So now substitute the value of sin omega t and cos omega t from equation number 1 in equation number 3. Substitute the value of sin omega t and cos omega t from equation number 1 in equation number 3. Like previous case, a few steps, 3-4 steps I am omitting. That is, only you will substitute the value of sin omega t and cos omega t. Then, like previous case, square, rearrange, then squaring, then simplify. After doing those things, you will get the equation of motion. Final equation of motion I am writing like this. In the study material, perhaps I have done those things. Otherwise, you will do. If you will not be able to do these steps, you will say, I can do. All of you should try. Why? What you will do? Rearrange the terms like previous case, square and simplify. Squaring and simplifying these terms, you will get the equation of motion like this. Y by a2 cos delta square plus 4x square by x square by a1 square minus 1 minus y by a2 cos delta. This is equal to 0. This equation will be obtained. All of you will try to do this thing. This is your HW. So this equation is...
Sir, can you repeat the equation because sir, left part is not visible of the board.
This one. Y by a2. This term again only. Y by a2. This is visible. Y by a2.
Yes, sir.
Cos delta square plus 4x square by a1 square x square by a1 square minus 1 minus y by a2 cos delta equal to 0. This is the equation number 4. This is a 4th degree equation. This equation represents a closed curve. This equation represents a closed curve having 2 loops. Having 2 loops. Now this is the general equation. Like our previous case, we will take this equation number 4 as the general equation of motion. Now we will consider different cases when delta equal to 0, or cos delta equal to 1. To substitute here cos delta equal to 1, then we will get a by y by a2 plus 1 square plus 4x square by a1 square, x square by a1 square minus 1 minus y by a2 equal to 0. This can be written as y by a2 plus 1 minus 2x square by a1 square square equal to 0. Now we see this equation number 5 represents two coincident parabolas. Two coincident parabolas with their vertices at 0 minus a2. I think all of you are acquainted with equation of motion for parabola and their vertices, etc. So we can write from this. What will be the equation of parabola? That y by a2 plus 1 minus 2x square by a1 square equal to 0. So we can write this equation as x square equal to a1 square by 2a2 y plus a2. This is the equation of the parabola. Now if we plot the graphs using this equation, I think all of you will be able to plot this one. You will see this is the minus a2, this is the a2, this we can say a1, and this is a1. This is the x-axis, this is y. Now when delta equal to 0, it is very difficult to get the resultant motion in analytical method. In that case, it is better to take the help of a graphical method. Now let us consider the case of when we will consider delta equal to pi by 4. What will be the resultant motion due to the superposition of two perpendicular harmonic oscillations having frequencies in the ratio 1:2 and phase difference delta equal to pi by 4. In that case, we will take the help of graphical method, because in those cases when delta is not equal to 0, that means when the value of phase difference is different from that of 0, in that case it is very difficult to get the resultant motion by analytical method. So we are taking the help of a graphical method. So in that case, what is the procedure? We have to draw two circles. General procedure what already is equal to do inverse. Two circles. Circle radius will be different from first one to second one. We have taken here x equal to first one, your a1 cos omega t, and second one we have taken y equal to x equal to a1 cos omega t. Second we have taken y equal to a2 cos omega t plus delta. Okay. Now you see what you I have divided into 8 parts, and this one I have divided into 16 parts. The first one I have divided into the first one I have divided into, this is the first circle having radius a1. I have divided this circle into 16 parts and this circle into 80 parts. Why? Again, you see what we have taken. We have taken two SSMs having frequencies ratios 1:2. That means the frequency of this one is 1, frequency of this one is 2. What is the physical significance of this one? It will take 1 and 2. That means when this SSM completes one rotation. At that time, this means that second one completes two rotations. Am I correct? Yes or no? Hello?
Yes.
So now, if you will say that suppose it covers, now you comes to the parts. I have made this one 80 parts. So if you will consider this rotates twice, how many parts it will cover? 16 parts. Now I have divided the first one into 16 parts. So with one complete rotation, it will cover 16 parts. With two complete rotations, it will cover 16 parts. In order to make the number of parts equal, I have divided into 8 parts and this into 16 parts, because when the first one will complete one rotation, at that time your second one will complete two rotations. Clear to this point? Now comes to phase difference, numbering. Now comes to the point numbering. So the first one I have made the numbering 0, 1, 2, 3, 4, 8, 12, 13, 14, 15, 16. Like this. Similarly, here again it comes to the numbering. Numbering is very important, I say. Here delta. Now we have considered delta equal to pi by 4. Case 2. For case 2 we have taken delta equal to pi by 4. Now you see it is divided into 8 parts. Each part creates pi by 4 angle. So here numbering will start from here. Everybody clear? So 0, 1, 2, 3, 4, 5, 6, 7, 8. Now comes to another one. 9, because second rotation, 10, 11, 12, 13, 14, 15, 16. Numbering is complete. Anybody has any doubt about the numberings and the divisions? Because that is important, very important. Without these things, we cannot draw. Now, if you are clear about the numberings and the divisions, then the method is like this. Draw the perpendiculars or draw the same numbering points. Here, 8 and 1 point. This one, then 1, 1, then 2, 2, like this. Then you will get exactly, if you draw, then you will get like this type of motion you will get. Not all of you will try to draw exactly. And the direction of motion, starting from 0, 0, you will proceed and complete at 16, 16. Okay. So this is the case how you will draw the Lissajous figures. If the frequencies are given 1:2, delta equal to 0, already we have discussed. Delta equal to 4, pi by 4, we have discussed. Then you can note down other points. That case 3, that is delta equal to pi by 2 and 3 pi by 4, then pi. These 3, all of you take as your HW. This HW will be converted into EW, examination mark. So all of you will try to draw these Lissajous figures taking delta equal to pi by 2, 3 pi by 4 and pi. Okay, then what is the uses of Lissajous figures? This is the Lissajous figures. Then uses of Lissajous figures, you may note down some points. Lissajous figures can be used to determine the ratio of to exactly. Lissajous figures can be used to determine the ratio of to exactly proportionate frequencies. Number 2, Lissaj's figures can be used to compare to nearly equal frequencies. Those who are interested to do taking, in one case I have taken 0, in another case delta. If you want, already I have said phi 1 and phi 2, then phase difference will be phi 2 minus phi 1 or phi 1 minus phi 2. You can try also. It is also done in our book. Also, we have done both the cases. Taking 0 delta and taking phi 1 and phi 2. Then another homework you can take like that. If the frequencies are 1:3, find out the Lissaj's figure or resultant motion due to the application of two perpendicular SHMs having frequencies in the ratio 1:3 and delta equal to 0. Delta equal to 0 and delta equal to pi by 3, pi by 2. And one thing I have already said that I have given the frequencies in the ratio 1:3. That means in examination it may be asked, instead of a frequency, time period in the ratio 3:1. This is the same because the frequencies and the time periods are inversely proportional. So it may be asked in terms of frequencies or in terms of time periods. So along the uses, we have said the comparison of frequencies. The shape and nature of a signal waveform in electronic circuit can be determined using Lissaj's figures. Amplitude of a signal wave can be determined. We can use Lissaj's figures to investigate the vibrations of a Vavelin string. So these are some applications or uses of Lissaj's figures. So this completes the superposition of two perpendicular harmonic oscillations having same frequencies and different frequencies. Then in the next class, we will start about that what is given in your syllabus, next point. So linear superposition principle, superposition of two perpendicular oscillations having same and different frequencies, phases. Then pre-damped oscillation. That in the next class means tomorrow we will start about the pre-damped oscillation. Freshman roll call 1.